Welcome, folks. As you guys are coming in, get settled in for a good, fun-filled hour or so, hour-ish, as we're going to explore episode 14. So, again, as we're getting some folks in, awesome, seeing some familiar faces already on the chat, if you will, some familiar names. So, excellent. Glad you guys could join today. So, as we'll give folks just a few more moments as they're trying to get settled in. Go ahead and use that chat window there. You guys have been really good about letting us know where you're from in the world, and that way we can kind of get a good feel for, some of you are very late at night tuning into us, and we appreciate that. Some of you very early in the morning, and some of you like myself here in Oklahoma, we're right at noontime. So this is a great time to pull up for an hour and visit a little bit about Solidworks sheet metal functionality. And today we're going to look at, using that a couple of different ways that might not be normal. Certainly not as the name suggests, being sheet metal. And so we're going to have a little bit of fun with that today. And so, again, I think probably in. All right. Somebody already asked, what license version I think that you're asking for. Everything that we're going to cover today is going to be a part of SolidWorks Standard. And it's a great thing that to be able to do a lot of model geometry and to explore a lot of design in a lot of these fun projects with SolidWorks Standard. And we've got other functionality in our other versions as well. But thanks for asking that. But Viva la France in this morning. So thank you guys for chiming in and being a part of that. So. As I mentioned a while ago, this is the 14th version or 14th episode, excuse me, of Live Design, and there's several of you like Eric Beatty who's been in for each of those, and we very much appreciate you tuning in for all of these sessions, and we're going to continue to keep these up. So use that chat window as well to let us know what other topics that you're looking for. We've got a stacked team of very talented people that from design and manufacturing and have been spending many years in SolidWorks. Myself, a user since 97 version, and so I've had a really great career using these tools, and I think many of you enthusiasts that we see here on these sessions have as well. So we appreciate that. Appreciate you, carving out a little bit of time to spend some of that with us. And so let's take a look at, if this may be the first episode that you're joining. Again, welcome to the Live Design series with Dassault Systems SolidWorks, and let's take a look at some of the others that have been there. And so, during this time of working from home, we've utilized this time. And those of you that are a fan of the space series that I'm emulating there, you've got that theme song playing in your head, and so I know you can imagine as we look at the different episodes and the great work from guys like Toby Schnars and Brian Zayas, Andy Barnes, Mike Sobocek, Mike Sandy, Mark Schneider, Michael Steves, Jordan Tadich, Jeremy Ragnarash, Juan Chapa. Juan's a newer team member like myself, Andrew Gross, Steve Fick, and then last week's from Mark Peterson. And so as we get ready to dive into this episode 14, we're gonna look at that sheet metal functionality. And so, again, my name's Tandy Banks. I'm one of the industry process consultants with the SolidWorks team here in North America. And kind of common, people have been using Google Earth to show where they're from. I thought I'd go a little bit old school. This is Oklahoma, and all of our major roads there. And if you can see the little circle down here in the bottom, that's where Marlow, Oklahoma, which is where I was born and raised, and got to go off and work for some great manufacturers in the world, and then came right back here to join my family. And that's where I'm broadcasting from today in our downtown upstairs studios in here in Oklahoma. So with that, let's get started and dig a little bit deeper into what we've got going. Traditionally, when we're talking about sheet metal, it would be something similar to what I have here on the screen. And this is what we would call a dry additive hopper that might be used on a skid that is got some kind of chemicals that need to be dropped in. Jacob Elliott was one of the names on the chat a while ago. This might look familiar to him. Jacob and I worked together doing some similar products, but Inside here, we've got some piercing elements made out of sheet metal, and if I zoom into those, you'll see that there's a lot of tab and slot design. And so we do that for the design aspects, but we also do it to make it easy and fun for the welders to put puzzles together and to be able to work with that. But this, like I said, this one example. This is a traditional sense of what we would use sheet metal for. And I'll tell you, we're not going to spend our time today on that particular. But one thing I did want to highlight for you here is one of the reasons why we use the sheet metal functionality within Solidworks is this one little magic button up here called Flatten. It is a lot of what our end result for today is going to be on a couple of the projects that I wanted to show you. And so that flatten button is extremely important to the sheet metal functionality. But this would be the traditional sense of sheet metal. And I'm going to show you a few different examples today of how you might use sheet metal functionality a little different. So another of which is packaging. And I've done some content out there on YouTube and other places on packaging design in the past, but you can see something like a box. We can use the sheet metal functionality to create cardboard boxes as well. And so we'll dig into some of the features and stuff today that were used to create this. But again, that flat pattern is really what I'm looking for. And so being able to click on an entity, hit the flatten button, and know, the shape that we need to be able to cut out is a really important aspect of those sheet metal tools. So a while back, one of the things that we do as process consultants is we travel. And so a while back, I got the idea that I wanted to be able to have a travel bag. Put my passport in, put my wallet in, maybe some headphones and that kind of thing. And so I wanted a bag very similar, just a rectangular bag. But I wanted to add some elements to it. I wanted to have some pockets inside. I wanted it to be good for sunglasses or for cell phone or anything that I might be worried about getting scratched on. And so I found this really neat material that is, it's got silver threads in it. And that's the inside of that. I've just turned that bag inside out while I was sitting here talking, showing some of the pockets and stuff that were in there. And so I had this idea. My wife's a pretty good seamstress, my mother-in-law as well, but they always work off of a pattern. And so I told them, I said, hey, I can draw you a pattern. And they kind of laughed at me. And I said, no, I'm serious. I'd like this bag. I found this material that's silver, and so it's antimicrobial. And, for those that maybe not want to pass RF, the silver helps with that as well. And so it was kind of an all-around kind of cool deal. And so I used the SolidWorks sheet metal tool to create that pattern for them in order to be able to create this bag. So we can use that with fabrics as well. Even though the geometry within the system is going to be very rigid as we're designing, it can be a very flexible medium that we're working with. And that brings us kind of to today's main project, and that is that we're going to look at a fun project that I took on with my son. My youngest son is a bit of a gamer, and he likes the little handheld gaming consoles. And I was noticing that pretty quickly whenever he started using this game system, that the little kickstand on the back disappeared very quickly, right? And so fell off and had some issues. And so he's like using the little holder for coasters. He's using anything that he can find, some easels for pictures. He's finding whatever he can to prop up his game system while he's working. And I noticed that he was having some issues. And so I told him, hey, I'm going to be doing the sheet metal thing. Do you want to work on this cardboard project together? And so that's where we came up with our real deal cardboard holder or console. I'm showing my age there a little bit. I had a colleague kind of bust my chops a little bit on the name of my session here today, letting me know that hey, are we actually making a game console? Well, in my day, the box that held the game was the console, and so we're building the box here, or the easel if you want to think about it that way, in order to hold this. And this is real deal out of cardboard, cut by hand at home, decorated by my son as we work through this. And I was pretty impressed with his SolidWorks logo that he's got going on there. And so that's what we're going to be focusing on for a majority of our time today. And so with that, I'm going to check chat here real quick before I move forward, make sure that we're doing all right. got folks from all over the world. This is awesome. Glad that you guys are here today. South America and Europe and Asia and UK, and that's awesome. Good to see you guys here. Um, welcome, welcome, welcome. So again, my colleagues that are on as well, they're going to be helping with answering any of the questions. And so, throw the chats up there, throw ideas for other sessions that you would like, and we'll continue to answer those questions as we can along the feed. And then towards the end, I'll take some Q&A. I'll review this again, and we'll get you as many answers as we can. So a little quick time check. I need to get busy, work on this part. So let's take a look at what we got going on here in SolidWorks. This is the finished product that we want to work with. I am using a 3D mouse today, so as you see me rotate these around kind of nice and smooth, I am using, again, a 3D mouse in order to be able to do that. I love that days of doing a lot of heavy assembly and design. That was a very handy tool. So take a look at some of those if you can, and aids in productivity. You can keep your left hand on the visuals all day long and the right hand on the to-do stick with that with your mouse, and you could be very productive. And so if we take a look at this assembly, what I'm going to do is I'm going to start off and I'm going to hide the component that we're going to build. I'm left with that game system that we want to design around. Now, I'm an old school guy, and so old school equals layout sketches, right? I kind of set myself, whenever I do almost anything, I find myself starting with 2D, building those layout sketches, and then starting to go from there. And that's, I use SolidWorks for everything. We've had a lot of episodes this summer using weldments, and I was kind of jealous because I love weldments too, and I've used that. During this time when we're working from home a lot, I built an entry closet, and I used weldments for all the studs and everything there. And so instead of another weldment example today, we're going to focus here on sheet metal. But those layout sketches, those 2Ds are really important. And that's exactly where I started off. I started off with just a 2D sketch, and I threw me a couple of lines out there because this is somewhat ergonomically related. I wanted to get a pretty proper viewing angle. I wanted to set kind of some distances away. And so this layout sketch represents that, how far I wanted it up off of the table, the viewing angle, about how far away that I wanted the perspective to be. And then I used that sketch to mate the game system down here on the bottom center. And again, I've just got a couple of dimensions in here. This 1 3-inch dimension here is really roughly about how wide I thought that I wanted this. It was my first stab at kind of getting some dimensions out there and understanding how I wanted this to be placed, about where I wanted the center of mass to be. And even though I don't have everything designed and it's just a simple cardboard easel, I still wanted some of these ergonomic aspects to be a part of my design. So that was the elevation sketch, and then I had a plan sketch that I started off with. And we'll just go ahead and activate that. I'll go to a top view. I used the Control 5 key. Again, kind of being an old schooler, been around SolidWorks for quite a while. I'm still pretty particular about the commands and stuff that I use. I still run it the way I did in the 2000s. But the Control key, along with the numbers up at the top, is a great way to put that left hand to use. And so Control 5 is a top view. Some people prefer the view cube, and that's fine. The view cube is what you can activate with the space bar. All right, so space bar, and then you can click a face, and you can get there as well. Everybody's got their own preferences of how they like to work. And really the dimensions that were what I thought were important to me is very front to very back. I thought somewhere around 5 inches. I wanted that mostly to be forward, just to kind of help the balance. And so again, as I'm kind of looking at this, seeing what I wanted, this is roughly what I sketched out. And whenever I looked at that in comparison to the console, things were lining up about where I thought I wanted them to be, the game system. And so one of the things I wanted to be particular about is I wanted to make sure that I stayed away from these controllers on the left-hand side and the right-hand side. I wanted to try to keep, because there's some buttons on the back, and I wanted to make sure that I kept that inside. And so this is roughly where I sketched out. And so I got a plan, I got an elevation, and now I'm ready to start going with this. I love being able to build geometry within the context of an assembly. And so that's really what I wanted to do here. And that's, really where I've spent a lot of my career. And in its truest form, it's top-down design, but it's not master model like Mark Peterson showed last week, which is, an awesome technique, being able to do master model. This is similar, but still different. So before I dig into that, I'm going to check the chat here real quick and see what's going on here. Eric, thanks. Yeah, he was pretty proud of how he did the Solidworks logo. And Jamie, yeah, this is exactly why we're, part of the intent of doing this series is that we want to make sure we're getting some good base foundational skills that we're sharing with you guys, so that way you can be as productive as possible and have as much fun as we do using the software. And so, all right, 3D mouse, awesome. All right, so somebody asked, this is one of the questions that's been going on through all these episodes, millimeters or inches? I'm Imperial. I still haven't made the switch. With 2 different companies I've used metric and that I've worked with in the past, and so I still kind of stick over on the Imperial side of things using inches, just because that's where most materials around here are built off that, our page sizes, everything that we work with. So I did use inches in this design. So great question. Thanks for asking that. All right, so from here we can get started, and in the assembly toolbar, this is one where we can insert components. And a lot of folks, they look at insert components meaning a bottom-up design technique, and that's where we've got all of our components already built and we just want to assemble them. But if you use the drop down there within the insert components toolbar, we can come down and choose new part. And so I'm going to insert a new part into this assembly, and what it's doing for me there is a little flash, and it went in and inserted a brand new component as an internal component. And that's one of the default settings within SolidWorks, is that when we create new components, they're going to be saved as an internal data set within the assembly that I'm working from. Now a little later on, I'm going to kick that out so that it's going to be its own SLD PRT file. It would be its own solid model part file. But for right now, I'm going to do my design work and have it all internal to my assembly. But if you'll notice here on the screen hanging off of my mouse cursor is a little check mark. And so anytime that it doesn't automatically pop up the way that I think or what I'm expecting, always look at the status bar. The status bar is at the very bottom of right below the feature manager area, and it's letting me know that it wants me to select a face to place the component. And whatever face or plane that I select is going to become the front plane of my new component. And I like my planes and axes and my coordinate systems to match up. And so I'm going to select the front plane up here in the feature manager area. And so that way it's going to put the front plane of my component right on the front plane of my assembly, and they're going to match. Right and right's going to match, top and top's going to match, and so it puts me there. It also automatically kicks me into a sketch on that front plane. Now, because I want to start with my plan view, which is on my top plane, I'm going to kind of start extruding that up to begin with today. I'm just going to simply use the confirmation corner, and I'll accept the sketch in order to get out of that front sketch. Over in the feature manager area, it's now highlighted that component that I'm working on in blue. That lets me know that I'm in an edit part mode. I'm not in edit assembly mode, I'm in edit part mode, and that's an important distinguishment to make whenever we're working with assemblies in the context of part design. If you'll also notice up at the top, I've got my editing references and then a line, and then starts either my sketch or features or surfaces or whatever ribbon toolbar that I'm working with, right? So you kind of you get best of both worlds there. It's also letting me know up at my top bar that I'm working on a component within the assembly. So I get a lot of visual feedback from SolidWorks, and that's one of the great things we like about it. And early on in my career, as I was trying to learn the system, it was very helpful for me to understand what was going on. Now, something I noticed there, for those of you that are staying really current with the latest versions of SolidWorks that's available, I am running 2020 Service Pack 3. And there's something a little different in Service Pack 3 if you haven't noticed, and for those that may have installed. We used to have a toolbar right up here to the right of our menu bar. And if you'll notice now, that's been docked over here on the left-hand side, where we can now see it, and it stays there active, constant. And those are for things like our new component, save, undo, rebuild, settings, those kind of things. And so a little different change in the UI there if you hadn't noticed that already. If you're a hotkey person, kind of like I am, most of those functions I get to with some form of hotkey. All right, so I'm editing component. I'm going to expand the feature manager area of that particular component, so that way I can get to the different levels within it. And if you'll notice, we see the front, top, right, and the origin for my component. Up above that, I see front, top, and right for my assembly. I do have the sketch that I've renamed top plan. I have that shown, so that way I can see it there on the screen. And what I'm going to do is I'm going to reuse that. I'm going to start a sketch on the top plane. I'm using my pop-up tools that I get right at my mouse cursor, trying to minimize that mouse cursor travel as much as possible. I'm kind of a geek when it comes to that. I'm very lean-minded. I'm trying to minimize the mouse movement and the mouse clicks as much as possible. My family calls it laziness. I just call it efficiency. And so I try to ride that line as much as I can between efficiency and laziness. So I mentioned I want to borrow geometry from another sketch, and we've got a lot of ways that we can do that. But one of my favorite ways is to highlight the sketch in the left mouse button, highlight the sketch, and then I'm using the convert entities function that's over in my sketch toolbar. It and offset entities are kind of sisters, but the convert entity is going to take whatever geometry is in that sketch and create that same geometry right into my component sketch. All right, so that was a great reuse of geometry. So whenever I select on convert entities, we'll see just that. Converts those over, and you'll notice that I have my relationships, my sketch relations shown. That's something I prefer unless I get a really complicated sketch. And so you'll see out there I could highlight over those, and those are going to be that relationship that makes that convert entity. So anywhere I move the top plan sketch from the assembly, it's going to affect that sketch down at the component level. So I've got my sketch geometry the way that I want them, and I'm going to move right on over into the sheet metal toolbar. I've got a lot of stuff to unpack here in the sheet metal toolbar. Just doing a quick time check. All right, so whenever I go over to the sheet metal toolbar, you'll see there's not many commands that are active and available to me. And that's another great thing that Solidworks over the years, the developers for our user interface, has really helped us out by kind of narrowing the focus on what we need to do for our next step. And so these are a few of the things that I can do with the sketch that I have active and available. And so the base flange actually is the thing that I want to start off with. And as you can see in the little flyout description in the picture that's there, that's basically what I want to do. Is I want to take my sketch entities and I'm going to extrude them up in order to create my first sheet metal features. But what we do when we're creating that first base flange is we're also setting up all the parameters related to our sheet metal properties. All right, so there's a little bit more going on in this very first dialog box. So I'm going to spend a little bit of time unpacking some of that. Over on the left-hand side, one of the things that we teach, if you've ever gotten an opportunity to sit in one of our official classes, is we kind of like to work dialog boxes from the top down. And so I'll do that, expand an area if it's maybe contracted. And the first one we come to right here is it's going to want to extrude in a blind direction in the positive direction from wherever I sketched. So since I sketched on that top plane, it's trying to go positive Z, and that's exactly the direction that I want it to go. I am going to use blind, which just means, we're defining a specific distance that's going. And I've already, in talking to my son, we got the scale out, the ruler, and we decided that about 8 inches looked really good. And so I'll just key in 8 inches there. That was one that we wanted to get started with, and I might rotate that around a little bit and say, yeah, I think roughly that's going to get me the size that I want to work from. One of the cool things I like about doing top-down design like this is I get a little bit of a visual with our preview of where those lines are going to hit. And I've got these really, kind of open angles on this because I know I'm using cardboard and I want to give it some stiffness. And so, there were some reasons why I chose kind of this big open sketch that I'm working with here. But, things are looking the way that I want to as far as an extrude goes. So let's move down into the dialog box and look at some of the sheet metal specific parameters. We do have the ability to use gauge tables, and I would definitely suggest maybe going through the online tutorials within SolidWorks to explore more about gauge tables and what we can do with those. Because I'm not using sheet metal today, actual sheet metal material, since I'm using cardboard, I don't have a cardboard one set up. Much like with my fabric, I didn't have a fabric one set up because these were kind of one-off projects. And so I'll just kind of skip that. But certainly if you're going to do something like if you work at a component manufacturer or something that makes true sheet metal or any kind of materials that you're going to use with this functionality, you might explore using gauge tables. It helps you consolidate the settings that you might need for each one of these. And so definitely take a look at that. But for me, I've kind of measured some cardboard that I had available laying around the house, and about 30 thousandths was the pretty nominal. This one that we actually ended up using is a little thicker than 30, but it was close enough to get what we needed. As far as the bend radius, it really kind of depends on your material. And a good rule of thumb for those that are using sheet metal, if you're doing any kind of standard seals or stainless, a 2-to-1 ratio, meaning that your bend radius needs to be at least half of what your thickness is. And really, we like to even use a 2-to-1 depending on what you're going with. It's twice as a larger radius as your thickness. Depends on your processes, whether you're doing true air braking or whether you're doing deep drawing or all those kind of things. Would love to have a conversation with you if you want to know more about how we do different manufacturing processes within this. But again, since we're talking about kind of using sheet metal for other functionalities today, we're going to use these here because cardboard really doesn't have much of a bend radius. It's going to crush, corrugated cardstock. It's going to crush. It doesn't really stretch. Some of those kind of things. And so likewise, this bend allowance down here below, I set this to a 0.5 K factor. And K factor is something that I could spend 3 hours probably talking about K factor alone. But just know that the simplified explanation of what this is this is the percentage of the thickness of the material. So 50% of the thickness of the material is where the theoretical neutral line is. When I take something that's flat and I bend it, there's a neutral line depending on the material about how that's affected. And like I said, with steels and some grades of aluminum, those kind of things, it's a smaller than 50% K factor. And the reason why is we compress less and stretch more. And so that percentage is off of the inside face of the bend. So if I were to bend this over from the inside face, what percentage of thickness, where does that neutral line fall? And again, for cardboard, 50% is going to get me really close. And if you're doing very large open shapes like big rolled tanks or cylinders, that's going to be 50 because it's going to stretch as much as it's going to compress. Lots of really good material out there. Do some searches for K-factor, sheet metal, bend allowance. And just so you'll know, we've got multiple ways that we can calculate that bend allowance. We actually have bend allowance, bend deduction. There are tables that can control it for very specific parameters. But a general K-factor of 0.5, the material is going to stretch as much as it compresses, and it gives me a nice, even neutral line. Okay. So I know I'm talking a lot in this first dialog box because there's a lot going on here, and this is going to set the defaults for any of the other features that I'm going to create. And so that's why I spend a little bit of time looking at this. Now, auto reliefs in this particular project, not as a big a deal. Certainly whenever I'm doing steels and any kind of materials that are rigid, I'm going to take those into consideration a little bit more. And what those auto reliefs are is if I make bends that are going to cause a pinch or a kink, how do I want to work with that? And so we've got options underneath there. For this one, I'm going to just stick with a rectangular because again, I'm not dealing with any reliefs around those. So I'm going to hit the green check mark, and finally I get that first extrude, or that first feature that's there. Took me a while to get there, huh? So I'm going to take a pause for just a second, look down through the chat here. Man, I'm getting props from my daughter this morning too. Thank you. All right, that's awesome. So got my kiddos involved. I have 5 kiddos, and so that's how you really get a lot of YouTube likes is you get your family involved. So that's awesome. Thank you guys. All right. Game system model available online. Yes, it is. I actually got that from a library. If you'll just do a search out there for your particular game system that you like. There are a few CAD model libraries out there. I believe this one came in as a step file. Actually, this one may have been a SolidWorks model. I just imported that in and started to build around it. I did verify, and this is one public service announcement for you. If you ever download models, especially if you're doing real work, if we're actually building, some real geometry, always verify the dimensions. Horror story real quick, I designed a large skid around a hydraulic pump that I got from the manufacturer. Actually, I got a model from the manufacturer, designed my skid around that, and whenever it came time to produce it, the model didn't match the actual real life part, and I had to redesign a lot of stuff. And so from that day forward, that was my lesson learned. I got burnt, and so anytime that you're downloading models from somewhere else, always verify the dimensions. Just do a quick XY and make sure that the overalls match. But yep, great question. Thanks for asking. I did download this. I did not model this one myself. So all right, so I'm gonna keep going here. Got some discussion going on about hardware. That's great. Not particular to ours, but that's what these communities are about. You guys share resources and talk up some of those kind of things. All right, so visually, especially whenever I'm talking to somebody or helping design something, and maybe they don't see things the way I do in my head. I don't know if you guys ever suffer from that. You're like, I got to figure it out. I see exactly where I'm going, what I'm trying to do, and the people working alongside you're like, I don't quite get it. Well, that's what happens, and that's one of another great aspect of what we can do is we can make this look very visually appealing and very close to real world, just right here in our regular screen. And so what I'm going to do is I'm going to apply let's apply material first, and then I'm going to apply a texture to this. Material is important for a few different reasons, especially if we're trying to do any kind of weight study on this. Maybe we're trying to do a simulation, like a structural analysis or something like that. All of these materials play into that. For our instance, we really just want it, if we want to do a catch weight for how heavy is this cardboard going to be, or how much material we're working with. So there is a corrugated paper material that's found under our other non-materials, and if you notice, it was just a right click. If you guys haven't heard it before, when in doubt, right click. That's our SolidWorks kind of unofficial motto. And so I just right clicked on the material properties. It brings up this dialog box. I can do a search, or I can just browse through the different folders to see the materials we have available. And you do have capability to create your own custom materials as well. But corrugated paper is one that we've got in there. Now, whenever I look at the appearance that's signed to this particular material, whereas that's fine. It's aesthetically pleasing. It's not exactly what I want, but I'm going to go ahead and say OK, and I'll close out of the materials dialog box, and you'll see that corrugated paper is now shown as my material over here in my feature tree. So I applied the material first, and then I'll come over here and I'm going to grab a different texture because I want it to look a little different. I want it to look, a little more than just a flat cardstock or something, and explore these. We've got a lot of different materials that are out there available, and whenever I'm trying to pick a texture or a material visually over here, I'm trying to find something that's close, because I want the sheen to be close. I want any kind of refractory or anything else that's there. And for what I want to do, this sponge is kind of good. It's not real, it's opaque, it doesn't reflect a lot, and it's got a picture or a bitmap or a PNG. It's got some kind of image assigned as part of the texture. That's kind of an important thing for what I want to do. If you were to go up and pick up something like a plastic or a steel or something like that, it probably doesn't have a picture associated with that particular type of material, and so it would make it a little difficult to do what I'm getting ready to show you. And so I'll just grab the sponge, I'll drag it, and I'm dropping it onto as a left click drag, and I dropped it onto my component that I'm working on, and that's going to take the entire component and make it have that color or that texture that's associated with it. If you're new to kind of the visual or the textures or something that's there, we've got a little icon up here that's our display manager. So I'll select on that, and it shows me all of the different scenes and lighting and camera that I've got in here. Mike Sandy does a really good job of not only working with these things within the SolidWorks window, but also in our photorealistic rendering tool called Visualize. And so catch some material from Mike Sandy on things, all things that are kind of textures and visualization. And there's many of our team members that are really good at this stuff. But I'm going to highlight the appearances here. It kind of looks like a beach ball. Whenever I teach this, I talk about the beach balls up here. And we can see my sponge there. When in doubt, right click. All right. So I can go to Edit Appearance, and it's going to bring up that Appearance dialog box. And you got a basic mode and an advanced. Hey, we're in here to get deep, so let's go over to the Advanced tab and start scrolling down through here, and you can see what it's applied to. We can change whether that's applied to faces or surfaces of solids, full solid bodies, features themselves. But really what I want to do is I want to come down here to this image. I'm going to browse over, and I picked up a cardboard JPEG off of the internet, and I'm just going to use that as my image. And you can see automatically it pops in there. We already get that visual aesthetic of, this is cardboard that we're working with. So that's pretty cool. If we also wanted to colorize this, we could come over here and choose a color. And so we could have cardboard that was green. And so that's pretty cool. Or we could have cardboard that's gray. And so not ready to really colorize that yet, so I'm going to turn off the color, and we'll just let the image file shine through. The mapping tab is one that you can spend a lot of time in here playing around. By default, it throws an automatic mapping on there. You may or may not want to choose, say, a projection or a cylinder. It really kind of depends on, what kind of effect that you're trying to make. But you could explore and spend a lot of time on offsets, as well as back on how big something is, whether we want to tile it, those kind of things. Everything else is pretty good, pretty set up the way I want it to be. So green check mark, and I can get out of the display manager and get back to work on my project. But I wanted this thing to look like cardboard, right? So it's kind of neat. I'm using some other visual aspects in here. If I'm doing a very large assembly, I'm not typically working with these same visual aspects. But here today, I'm working with a very small assembly. It's small physical size, and it's small number of components and complexity and those kind of things. So depending on your hardware and your graphics card capabilities, you can turn on things like, I've got shadows turned on. I've got ambient occlusion turned on, and you can play around with what those look like when you have them turned off, whenever you have them turned on. Ambient occlusion gives you a little bit of that realism, has shadows that kind of look a little more real. Textures aren't just flat. So I like working with that, especially when I'm doing something very visually aesthetic, on these kind of things. And so that's a few of the settings that I have turned on. The screenshot that I did for the YouTube splash that's in there, I did two versions. I did one where I turned on perspective and I used the Solidworks screenshot, and then another version that I used our Solidworks Visualize tool in order to create that more photorealistic rendering and get the glass to refract the way that it's supposed to and everything else. Really, really, really cool stuff. But I do want to point out I am using some of those visuals. And then also up here in our heads up toolbar, whether you've got edges shown, whether you've got it just set as edges not shown, hidden line visible, those kind of things. And so while I'm designing, I may want to switch over to hard edges being shown. And so that way I can kind of see where my tangencies are. And a lot of times with sheet metal, I'm doing that. I'm turning that on so that way I can see these tangencies and see where that material breaks and bends, what's flat, what's in the bend area. Okay. Awesome. I'm going to go ahead and turn off that top plan. I'm not using that one anymore. And then we're going to start working on, start knocking this thing down. In general, we like to add material first, then cut away, and then add edge conditions. Again, that's kind of some best practices or tips and tricks I can tell you. When I'm designing something like this, especially off the cuff, like I don't exactly know what I want yet, it's a little bit of give and take. I'll add some material, I'll take some material away, I'll add some material, take some material away. And so, hopefully you can see. But again, if you've never heard that before, good rule of thumb whenever you're doing part geometry is to add all your material first. So that'd be extrudes and revolves and sweeps and those kind of things. Cut away material second, do your subtractive processes, and then do use edge conditions like fillets and chamfers as a tertiary effect there. If you'll use those, really good best practice to give you a lot of success in running SolidWorks. All right, so I've got my plan. I've got my default features for sheet metal. If you look over here in my feature tree, you'll see that sheet metal has a folder. It's now created the sheet metal feature, and if I ever needed to get back to some of those defaults, I could select on that top feature, choose edit feature, and then this is where some of those parameters are kept. Default bend radius, default thickness, default K factors, and bend auto release. So if you ever need to get to kind of a wholesale change, you can do that. And then each of the features themselves, like the base flange that I created, are going to adopt those defaults. So whenever you edit feature, this is one of the few times in SolidWorks whenever you edit feature that dialog box is going to look slightly different than it did whenever you originally created the feature. But it's just a shortened version because we're using all those defaults from that sheet metal feature at the top of our tree. All right. So now let's do our cutaway from the side. And if I pull my example over here again, this is kind of the look. We want to create something down here that the game system is going to sit on. We want this window opened up, and we wanted it mostly open. That was kind of the design we sketched out and talked about. So, how do I get the room in there, the main, second feature for my cardboard system? I'm going to switch over to a right view, and I'm going to start a sketch because I'm going to cut that from the side. And before I go into a full right view, I might want to grab a couple things. I love that Convert Entities tool. And so I'll come over here and I'll select geometry this time, say an edge, and choose Convert Entities. And then maybe I want to grab the very bottom of this and choose Convert Entities. And so what it does for me is it brings those two edges as sketch entities over into my sketch. All right, and if I select on that, you can see it's got an on-edge relationship. That's where it gets its definition. And one of the things people will see is they'll notice that the endpoints are black. And if you guys have ever heard Toby Schnarr's song, why are things black? And that's because they're fully defined. Blue things are underdefined, red things are overdefined, but things that are black in our sketches by default are fully defined. And so when we use the on-edge relationship, a lot of times people think those are locked down and can't be moved. And actually what we can do is we can select on that endpoint and drag it. And I'm usually pretty pronounced. I usually exaggerate my movement a little bit just to make sure, because if you're trying to move something just a little bit, you've probably noticed in the software before it's kind of jumping to something else, or if it's getting a separate constraint or something like that. So be a little bit exaggerated in your movement whenever you do that. And now, if I get that unhighlighted, now you'll see that endpoint is blue. That's probably hard to come across in the YouTube screen, but just trust me, it's blue. The other thing I want to do is that other entity, I really am not going to use that specific entity, so I'm going to use the for construction, and I can either get to it over here in the dialog box, or if I hadn't moved my mouse too far, it's in that heads up toolbar. There's a button to convert construction to full geometry or full geometry to construction. And center line, construction line, hopefully you figured that out in our sketch tools. Those are synonymous. They are the same thing. All right, now I am going to switch to that full front view. That's Control 4 on the keyboard, and so that's one that I use. I'm going to grab this endpoint up here, and I'm going to drag that up a little ways, and I'm going to finish out my sketch. I do love the S key, S for shortcut, right? And so from that S key, we can get it very quickly over into our tools. Brings all the tools right to my mouse cursor. I can get into the line tool, and I can start to draw. Now what I want, my design intent here is that I want this top edge to be perpendicular to that slope that I've got on that game system. So I'll just mouse over. I just hover my mouse over that last line, and then it'll allow me to create, using these yellow inference lines, it'll allow me to be able to create a perpendicular relationship, and then I can drag up and I can make that exactly vertical up there at the top. Another little tip and trick here, while you're in the sketch mode, if you want to stop sketching here and go sketching somewhere else, you can just double click with your left mouse button. It discontinues that sketch segment and allows you to start another sketch segment. It's really cool, especially whenever I'm not kind of going in one direction, when I'm talking more than I'm doing anything else. And I want to be able to set that. Escape key gets me out of the sketch tool, and now I can use that S key again to go over and start dimensioning some things. My design intent here is that I want the bottom of this box to be about 40 thousandths, that cut to be about 40 thousandths off the bottom. And then I'm going to want, again, measurements here. I want roughly 5 inches. And if you guys know or don't know, as you move our Smart Dimension tool, it's going to try to do vertical offset, horizontal offset, depending on where we move our mouse cursor. But if you right click, it'll lock that orientation, and that way we can come over. I'll specify that to be 5 inches, and then we're going to catch this front. I'll give it, 1.5 inches. What's that look like? It's not bad, but maybe not exactly what I want. Let's look at 1 inch. Ooh, that's too much. Let's go like 1 3/8. Looks good to me. It's about what I want. And if you'll notice, I'm living dangerously here today. I'm working with an open profile, meaning it doesn't come back and touch off on itself. And that's one of the techniques that we can use in our cut tool, is we can use a single contiguous profile, and it's going to create a slicing plane, much like a surface would. It's kind of like a surface cut for solids, right? So in my features toolbar, I can go over and go ahead and pick up the extrude cut. It's also shown in the sheet metal toolbar as the extruded cut tool. So we can get there either way. It's the same tool. It's just shown in 2 different toolbars. Extruded cut. Whenever I do use an open profile, there's a few things that I need to really pay attention to. One of which is I really only use this if I'm going through all in both directions. That's my own personal preference. So the first thing I do is switch my direction to through all both. And then the next thing I need to look at is the side to cut. That's represented with the arrow that's down here on my sketch, whether I'm going to go inside or outside of that sketch geometry. Well, I want to cut out the inside of that. So I'm going to go ahead and hit the flip arrow. Oh, excuse me. Let's flip side to cut. That's the one I'm looking for. Flip side to cut to make sure that arrow is in the inside of my sketch entities. And through all's there. I'm good and happy. Green check mark. And we're going to see it's going to cut that away. And now we start to shape up, start looking like what we've got going on. All right. We'll take a quick peek at the chat here real quick. Got some other ideas of how you could tackle some of this geometry. I love you guys sharing ideas. Sorry, you're looking at the top of my head there. Sharing ideas, looking at different ways that you can do things. That's awesome. Really appreciate that. S-Key, 3D Mouse, great conversations. That's all going good. Again, thanks for team members that are joining in and helping moderate the chat today. Really appreciate that and support of coming out for episode 14. I can't believe there's 14 of these already. All right, so I'm going to continue on with some sheet metal features so we can get to the end of this part today. I spend majority of my time over in the sheet metal toolbar whenever I'm working with these, and we've got some great tools. I really contemplated on showing convert to sheet metal because that's such a powerful tool and used a lot, but didn't really work for the workflow, the design process we actually went through on this, so I thought it would be good to stay away from that. I've used lofted bins a lot for different geometries. These are great for transitions and hoppers and especially like HVAC stuff whenever you're going from rectangles to circles and all those kind of things. And so lofted bin, great tool. But I'm going to camp out over here in edge flange. This is my buddy. I use this tool so much. And as the name implies, we're going to be able to select an edge up here at the top, and then we can drag a flange off of that. And so I left clicked on the edge and I moved my mouse and clicked again to place roughly where I want this thing to go. All right, I'm going to pause for just a second. All right, grab a quick drink and then let's proceed on with the process. By default, that edge flange is going to be at a 90-degree angle to whatever edge I selected, but we don't have to stick with that. And I didn't really pay attention to what angle I placed on this, so I could do some math, but again, that's too hard. I don't want to do that today. Let's just kind of focus on where we were going. So what I can do is down here at the angle, there's a select face area that I can select in. When that box becomes blue, it's ready for selection, and I can come down here and select on that very front face, and by default it's going to make that parallel to whatever I select, and that's exactly the design intent that I wanted here, is to be parallel. Continuing on down through my edge flange definition box is the flange length. Again, I could do some math and try to figure out what's the distance that's created over there side to side, but kind of lazy / efficient. why don't we just use a vertex? And so in my drop down here, I've got the ability to select a vertex or a point to choose how far out that I want that flange to go. And so I'm going to zoom out here a little bit. So I used a face to determine the angle, and then I used a point or vertex in order to determine how long I wanted that flange to be. And I'm going to switch to a top view here. So as you're keeping up with me here, that's a Control 5. And the reason why I'm doing that is I want to zoom in here and I want to understand, how is this bend area related to what I originally had sketched? And so as you see down here, we've got a whole host of different flange position options. Do we want our entity to be inside of our original geometry? Do we want the thickness of the material to be outside? Do we want the thickness and the bend radius to be outside? Do we want to determine what the apex is and the angle off the apex? I mean, we've got a lot of options here. And then we've also got, in combination, we've got this offset ability to where, yeah, I really kind of want it to be within my original geometry, but I've got to worry about this other end. And so let's kind of zoom out here and look at this other end. And we'll see that I want to make sure that I've got a little bit of a gap in here. And so I'm using 45 thousandths, 0.045 inches as a gap to make sure that I'm maintaining a little bit. I'm working with cardboard here. If you're working with high precision sheet metal, maybe this isn't the option for you, but that's okay. That's why we have options. We have the ability to set those the way that we want. All the other stuff below has to do with bend reliefs, bend allowances. I'm keeping everything by the default. And so with that, I'm happy with it. I'll hit the green check mark and zoom out, and you'll see that it created a flange starting from this edge all the way over. Whatever the thickness of the line was, or the edge that I selected, that's the thickness of the flange that comes across. And I'm going to move over and do a second one up here at the top. Keep this workflow going. Edge, flange, and it works whether you pre-select or post-select. I'm a pre-selector. I like to select the geometry first, then go into the tool. And so you can pre-select or post-select either one. I'm going to use that same function where I'm going to come over and choose a parallel, and then I'm going to choose to go up to a vertex. So we'll select the vertex, and then I'm going to go back to my top view, and I'm going to check and see, hey, is that giving me a gap that I want to? And it's not quite enough gap, and so maybe I want to increase my offset a little bit. Ooh, that's a little too much. Maybe we'll somewhere about there. I know it's a little hard to see. I'm looking at how it's coming across on the go-to or the YouTube here, but I do have a little bit of a gap there. That's what I want. So I'm going to click on the green check mark, and it creates that for me. And now as that's solid and not just the preview, you can see that that's a little better. Now, one of the things my son and I sit down and talked about was that we really didn't want to use glue. We didn't want to use staples. We want to use tape if we didn't have to. It'd be really cool if we could do this all with just cardboard, just with the cardboard cutout. And so that was the challenge for me, and that's good. That's part of what made it fun for me. And so that's exactly what we're going to do. And so as we look at this one, that very top, we want to create a slot, and we want to be able to stick this tab of this material down in there, and so that way it holds itself, because this whole thing was put together without any fasteners or glue or tape or anything else. It's just cardboard. So awesome. So let's do that. Let's go ahead and let's make this flap of material that's in here. One of the things that I did think about doing was doing something like a hem, and with the hem feature, you can select on an edge, and you can choose to flap over, and it's got a hem and flatten or a hem and open, and so you could do this open hem and allow you to be able to create that geometry. A lot of really cool things that you can do there between teardrops and rolls for hinges and those kind of things. But that really, again, it was going to require staples or tape or something. Not exactly what I wanted. So we'll back off of the hem tool and maybe choose one of our others. Joggle is another term that I've heard for this over the years. Jog is a great tool. We want to select a flange or a face or something that I want to work from, and then I'm going to sketch where and the direction of how I want that jog to happen. So I'll just come out here, sketch a line, and then I'm going to use the dimension tool to go from that edge, and we'll determine that we want that to be about an inch off the edge. Again, this is cardboard. It's a fun project. We'll get close to where we want it to go. One of the neat parameters or specific to Jog is when we exit the sketch, it wants to know which side of this sketch that we want to stay put. Which one do we want to be stationary? So I'm going to select the side, the largest side out towards the front, and it's going to start to produce this jog, which is like an S bend, two bends in and out of material. Well, I want to flip that guy over. I want him to go in the other direction, and I want to specify the distance in between the two faces that are there. And so this is all particular to your specific design and your parameters. And so all these dimensions I'm using here, you can remember the essence of the project that we're working on here. This is a cardboard project, and it's meant to just be a gaming tool. And so this looks good. I do like 60 degrees. I like to keep these between 30 and 60 degrees. That's my personal preference. I'm not. I don't use a lot of 90-degree jogs, but you can see it's 60 degrees from the original face that I selected. Now we're going to get a problem whenever I hit the green check mark here. Because I'm causing material to turn back on itself. And in general, when we're doing solid modeling, multi-bodies or whatever else, not a big deal. But when we're talking about sheet metal is kind of doing some checks for us the whole time to make sure we're not coming back and colliding on itself, because that's just a nature of the manufacturing process that's associated with this. Last thing I want to talk about before I leave out of here is this option called projected length. When projected length is turned on, whatever the original distance of that flange was, it's going to be maintained. So meaning it's going to add material to my design. And so I don't want that on this one. I want that bend material to kind of pull back or draw back that flange. And so I just use the fixed projected length and click on the green check mark. All right, so there's my joggle, but then I also get warnings. Dun, dun, dun. And it's telling me on my warning here that the part intersects itself. For the rest of this project today, and as you notice, the one that I already have completed, I'm going to have warnings, and I'm going to be okay with that. Again, it's specific to my project, and my needs here is that I'm using a tool a little different than it was designed, and it's going to give me some warnings. Now, those of you that probably have on automatic rebuild or using the what's wrong dialog box, you'll notice that I have show warnings turned off, and that's really for you for today to keep that dialog box from popping up every time. I'll tell you, as an end user out in industry, I leave that box turned on. I want it to annoy me. I want me to know that there's problems and warnings that are associated with that. But I do want you to know that is I do have those turned off while I'm working on the rest of this project today. All right, so I want to create a cutout over here. And I am noticing we are bumping up against time here, and I apologize for that. I got a little long-winded on my project today. So for those that need to bail off, I understand that. Like some of my colleagues, many of them have gotten long-winded and ran over as well. So you can, if you need to go back to work or whatever you're doing, I completely understand. Come back and pick up the recording afterwards. I'm going to try to get this thing wrapped up fairly quickly. All right, so one of the things that happens in here is whenever we want to create that area or that slot is I am going to run into some problems here, and I already know that just from using the tool over the years, but I want to show you what that looks like. I'll go ahead and give a couple of dimensions here. I don't need a very big slot, and I only need it to be slightly larger than my distance. So I'm going to go 1.4 on that, and if I kind of look normal to my sketch, I can place where I want that to go, and it's just slightly less than my original flange distance. So somewhere about 0.94, that gets me, and if I want to rotate this out of view, I can see that cutout right there should be good. But when I try to exit the sketch to do the cut, one of the neat things we get in sheet metal is the ability to link to thickness. But you can kind of see here, it already doesn't know how deep it's supposed to cut because I've got this conflict. I've got this material that's intertwined with one another, and it's not quite sure how to handle that. And so if I tried to finish this, it's going to give me a failure, and it just says I can't do that. And so I want to show you a great workflow in order to be able to work with that, because again, I kind of knew what I was doing there. I caused some problems, and so I'll just exit out of the sketch and I'll leave that there, and I'll be able to work, like I said, work around these things. Go back and see what's going on here. I obviously was talking and not paying attention to what I was doing. I'll back up to that one in just a second. But what we can do, I'll roll this guy back. This is the completed part, and will catch us up to where we were in our jog. What we can do is we can use a feature called unfold. Because again, I know that I've got geometry laying on top of one another, and that's not really the way the tool wants to work. And so what I can do is I can unfold just those bins. I can be very selective about what I want to unfold. And so that tool is called unfold, and it's found in the toolbars for sheet metal over here towards the right. And in the unfold tool, we can select which side that we want to stay put, very much like the jog was. And then we can select the areas that are the bend areas. We could collect all bins if I really want to unfold everything, but I'm not ready for that yet. And so I'll just collect those 2 bins and I'll say unfold. And so now it brings me back to a point prior to the jog, but the jog is still part of the history and in the feature tree. Okay? So that's the unfold feature. And then what I'm able to do is I'm able to use that cut sketch that I just created just a moment ago and go ahead and cut that through. Now, because I really truly only have one thickness of material there, it's able to cut through. It understands what it needs to do. And just so you can see those features, we can see that that is a normal cut. It is linked to thickness, turned on there, and it cuts through there. Because I've been showing you edge flange quite a bit, I'm gonna fast forward a little bit here. So let's come down through. I've created another edge flange down here on this bottom. But one of the things that's unique to this one is that whenever I was creating the edge, as you notice that my flange is larger than the edge that I created it from. And that's because every time we use the edit flange tool, we have an edit flange profile button right here. And whenever you select on that, you're going to get this dialog box that's in the profile sketch. And as long as that's open and active, then we're able to edit sketch of our profile. And so just simply dragging out the edges here and giving dimensions will allow us to create a different shape and or size than the edge that we originally selected. Finish here will complete that command, and now we can see that we have another edge flange right out here. Now at this stage in the game, I teased you with this a little bit earlier, and that's the ability to be able to use flat pattern. I'm going to kind of fast forward and show you, the rest of this particular project. And in that, we can see that the Flatten tool is available to us. It's only available when the flat pattern feature, which has been there all along as we're going down, is there and available. And what that Flatten tool allows us at every stage of the game to understand what our shape looks like. And as I was designing this, I kept going back and forth between flatten and folded because I wanted to understand, was I creating something down here in this geometry that didn't allow me to unfold this properly? All right, so that's the stage of the game I was in at that point. And then I came back and I used the fold tool, much like the unfold tool. So when we came in and select the fold tool, we can choose which face and which bins need to be folded back. And so we have something in the feature tree. We have the unfold and the fold that allows us to be able to unintersect the geometry, create the cuts, and then fold it back together and create the slots. The next thing that I wanted to do, and I'll stay here in this window, is I wanted to create a large rib back here in order to create kind of the shape that you see here looking from the top. I wanted to create this. But instead of creating 2 edge flanges, I wanted to use our miter flange tool. Really powerful tool that we've got there. And so I can go to the top plane and start a sketch. Use my Control 5 to get out of that. And then what I'm going to do is I'm going to come over and I'm going to create an L-shaped sketch. And I'm particular about choosing, if I did material inside versus material outside, I'm trying to make sure that I'm grabbing the edge, whether it's the outside edge or the inside edge, that's related to that original sketch flange that I created. That's one little tip that I'd add for you. It helps those go a little bit smoother. And then I want to create a dimension, give me a little bit of gap in between here. I don't need much. And then I'll give it this flange length here of 1 inch. So what miter flange is going to do is it's going to append the side face and give it 2 bends, a bend here and a bend here. All right, so back to my sheet metal toolbar. Remember, I chose the miter bend, or the miter flange tool is the one that I started with. I can say, okay, it understands, because of the way I sketched it, what I had it attached to, where I want it to be, and what I want it to work with. And so from there, it created 2 more additional bends for me on my cardboard, merged it all, kept it all connected. All right, so that's miter flange. I used our mirror tool from the features toolbar in order to be able to create a mirror on the opposite side. So that way I didn't have to sketch 2 different edge flanges or miter flanges in. And you can see that dimension that I put to the origin while ago is to create a gap in there. Trying to keep everything open. This is a cardboard project. All right. The next thing was I wanted to create some structure, some stability. And so inside here you can kind of see I've got a flange right here that goes through. And what I wanted to do is I wanted to create that fastening feature. And so I wanted to make kind of some fangs that were going to stick through the wall and be able to bend down and then bend in again. And that might be a little hard to see on the screen there, but that's the feature I was going for, is to be able to kind of bend it in there a couple of spots in order to make this thing assemble and attach to one another, rather than having to use glue or those kind of things. And so this edge flange that I created here, much like the other ones that I created, I did use the edit flange profile, and I drew in particular sketch geometry of exactly what I wanted it to look like. I added in some offset dimensions, so that way I've had some gap here, and I wanted a little bit more on the sides because I didn't know quite how our accuracy was going to be when we started bending this up and cutting it. And so I used the edit flange profile, sketch those in, and then whenever we get out of that command, you can see that I created yet again another set of intersecting geometry. And so I've got these what I call fangs sticking out here out the back of the cardboard part. So I used my unfold tool again, because that's one of my favorite things when I'm doing projects like this, to unfold just this particular edge flange, choosing this face as the stationary, selecting the bend area, and completing the unfold tool. Created a cut, just a regular extrude cut here in the back, because now I don't have that intersecting geometry, so I had to do that unfold first and then make my cut. Use a linear pattern to create 2 holes. Okay, linear pattern, we've been using that in some of our other episodes, and so that's great. Just instead of having to draw, I could have drawn 2 rectangles, but I do like to use the pattern tool quite a bit. I may have decided I wanted 3. After I got it bent, I may want to come back and make 3 of those. And then I'll scroll back down through here a couple times, and we get to where I created one more cut up front, and this was for the cable, because it was one of the things that wasn't in the original design, but we decided that real quick, that the cable is the charging port, that I needed a slot for that. And so we made that cut while I was in the unfolded state, so I didn't have any geometry that was overlapping one another, and then used the fold tool once again in order to fold those up. And the last one I want to show you here is we have the ability to sketch bend areas. And so I can select on a face, go back over to my sheet metal toolbar, and we have the ability to do sketched bend. And in here I can take something that's flat, that's in the sheet metal tool, and I can choose to draw sketch geometry where I might want something applied, add my relationships, dimensions as needed, and whenever I move forward with this, it too, much like the jog and like fold and unfold, wants to know which side is staying put, and then which side is bending and at what angle. And it will determine based off of that. I'm just going to go ahead and do a 90-degree bend here so you can see that. It will determine at that line how it's being folded and unfolded. And you can determine a lot of options here. What does that line represent? Does it represent the middle of the bend? Is all the material outside? Is the material in the bend outside? All those same parameters that we have in a lot of the sheet metal features and functions are there also in Sketched Bend. And so I'm going to suppress that one just because I've already got those. Apologize for having to finish this up on a pre-baked model. But you can see here, this gave me the effect that I wanted, and that is that we bent down once the fangs passed through the back of the box and then back in. And that gave us exactly the shape that we were looking for. Now, here in Solidworks, this thing is perfectly rigid. It's great. It's a wonderful thing. When reality came in, we probably would want to redesign the front of this, because again, when I originally thought this edge flange right here was going to stiffen up the front of this, but then when we had to cut the hole in it, it made it flimsier. So design 3.0 will be better, but that's what we ended up with on this particular one. I do want to show you two more things, and I realize this is 10 over. Apologize for that. I get excited about this. I want to show you guys a lot of just stuff. Some folks are talking about just waking up. That's awesome. Using clamps, I'll have to get back in here and figure out what's going on with clamps in there. Maybe like binder clips or something. That would be cool. We could do that. But especially, as many of you folks are working from home, maybe you always have or whatever, we don't have, typically, we don't have access to very large plotters or full-scale printers and those kind of things. And so whenever I look at the flat pattern of this, the question is, how do I go from this flat pattern to an actual part? What's the medium there? And so I chose to print this off on regular 8.5 by 11, and I'm sorry, that's getting in the lighting. But chose to print this off on regular 8.5 by 11 full scale. It took 3 sheets for this particular project. And so how do I do that? How do we get from here over into, let's say, a drawing? And so what I want to do is I'll create a new drawing. And I'm just going to use the base drawing template that we've got in SolidWorks. And let's see, an A4 is what that would typically be, or I could browse to one of my ANSYs, ANSY portrait. But even though I'm going to use that, I'm not going to use the format. All right, and so what I can do is I can grab that cardboard stand, the standard functionality when we create a new drawing, it says, hey, we've got this open in the background. Do you want to use one of these things? And if I use the next arrow here, it'll allow me to come down here and pick up something called a flat pattern. And so SolidWorks has that pre-baked in and allows me to be able to create the flat pattern of that particular part geometry out on the screen. I can change my scale down here at the very bottom to be full scale. And then I could start the process of, rotating the view around if need be. I could, change portrait to landscape, kind of depends on my printer capabilities. I can get this about where I want to be. And what I chose to do is kind of the easy way, but not the most technical way. And that is that I moved this, I hit Control P for print, and then I selected on the view, and I used my arrow keys to draw it up a little bit. I hit Control P again for print, and then I selected my geometry and used my arrow key again. I'm using the arrow keys to keep it from getting shifted side to side, right? Hit Control P again, and that's exactly how I got these 3 sheets of paper with my exact geometry of both my bend lines, because that's one of the things that's great here is it's showing me where these things are supposed to bend, as well as my outline. We used some tape, taped it to our piece of cardboard, and then used an X-Acto knife, like a scalpel or a very sharp knife. And of course, I did the cutting instead of my son. And we cut those holes, and then we were able to use the bend line. I used a pizza cutter, actually is what I used, to crease where we wanted the cardboard to be creased, and then folded the box up. And here you can see the end result. A little bit of decorating, a little bit of stickers, and we got the shape that we needed. So that's how we were able to take a flat pattern, and that's just part of adding a view on to a sheet, hitting the next button, choosing flat pattern as the option, and it will create that flattened configuration and allow us to put that on a drawing sheet or a PDF, 3D PDF, and send that out to somebody. Also along those lines, you can see I've got bin lines showing as well. Turn those off. You can at any time during, whether you're using the flatten tool or use the flat pattern configuration, you can right click on that face and choose export to DXF. And if you're using something like PDM or something else, we actually can automate that process. But we could create a DXF file of this flat pattern using the sheet metal functionality. To create that DXF file, we get a preview of what that outline might look like. We can save that, and if you do have the ability to send that to a laser or a plasma or say a drag knife or something to create and cut this cardboard out, you've got the manufacturing capabilities right there in that flat pattern as well. All right, I'm down to my last thing, and we will land this plane. Along the process, very much like I showed you with the packaging example, I may want to reuse geometry. And so we've got a lot of different things within the SOLIDWORKS design library. If you look under features, there's a sheet metal folder. And inside there's some different punches that are available. And we can drag and drop those off, and it's going to create that cut. Those are already pre-baked into doing a cut on that surface just by simply dragging and dropping that off. And so that's within our SOLIDWORKS standard design library that we have available whenever you install SOLIDWORKS. But maybe I wanted to work with something a little different. And so I've got a star over here that I've drawn. And maybe I want to place a star on here. Now this one, instead of being a cut, is just a simple block. And so I've got a sketch here with a sketch block. And then I could perform the cut. Could do that length to thickness or not. This normal cut, make sure because of sheet metal, we're keeping the edges perpendicular to the face. I can say OK. I'm getting that failed to cut because of the fold and unfold geometry that's here. So let's drag that guy up. Let's grab that guy and drag him before the cut, or before the fold, excuse me. Now let's cut the guy. Here we go, length to thickness, say OK, now cut. If that's a cut or something that I use over and over again, and this could be multiple features, it could be a boss with a cut, with a revolve, multiple features, multiple sketches. If I want to reuse that over and over again, I can highlight that, go back to my design library, and we have the ability to over here to create this add to library. Takes a second for that to pop up. It's kind of indexing the rest of the design library whenever I do that. But this is, if I do something 2 or 3 times, I'm adding it to my design library. Certainly those that are using PDM, you might want to introduce this to your product data management vault and have this available for any of your end users. As soon as this pops up, we're going to get a dialog box all over on the left-hand side where we can take this cut and now make it available within our design library over and over again. And again, you can do this with annotations. You can do this with sketch blocks, individual sketches, with features, with anything else that you may see. So there we go. We determine where in our design library we want that to be. It's going to give it a default of an SLD LFP file, library feature part. Give it a description so that way we let other people know that this is a star cutout for sheet metal. Hit the green check mark, and now that's available for anybody that might want to use that over in our design library. I wanted to touch on library features there for just a minute. Again, I know that's a little bit rushed today. I want to thank you guys again very much for coming out. I'm going to take a look at our chat real quick, see if there's anything that I can answer, and then we'll get this guy finished up for today. Yeah, summer is sliding by quick, and we're just in June, but yeah, it's going to go real quick. I think most of us are looking towards a fall and a future, and pizza cutter, press brake. That's right, Eric Beatty. That's exactly how we roll in the Banks household. So use the tools that we've got around us, especially as these home projects, whether you're working with kids or STEM, or you're just in the garage trying to finish your project and get those things done. And so. Um, Hopefully, I showed you some simple ways and some other ways that you can use sheet metal with fabrics, with cardboard, with a lot of different medium. And so hopefully, I exposed you to some things today. I did go a little quick there towards the end. Sped up the process with repeating edge flanges, talking about the fold and unfold tools. Showed a little bit about miter flange and a lot of those sheet metal parameters. And so again, thank you to my colleagues for moderating today and catching up with all these chat questions that are there. And with that, I'm going to say thank you again for joining us for this 14th episode. Look forward to the next ones that are going to be coming out. So stay tuned, subscribe, and thank you guys for using SolidWorks and being part of a great community that we get to do really neat things like this each and every day. So thank you.